graphing f of x is equal to cosine of x. So cosine of x is a lot like sine of x, except for you're using a different side ratio. So you take an angle, x, and you take the ratio of the adjacent side over the hypotenuse, and you get this ratio. So in this case, we'll let that ratio equal our f of x. So here I've drawn the unit circle. In a unit circle, the ratio is just the x-coordinate, and that's because the hypotenuse is equal to 1. So for example, for the angle measure pi over 4, I can draw a triangle here. This is my right angle. And if this is my angle, pi over 4, I want the adjacent side over the hypotenuse. It's a unit circle, so this hypotenuse is 1. So I'm really just looking at this length. Well, this length is my distance to the x-axis. And so this distance right here is going to be my x-coordinate. That side ratio side will actually be the x-coordinate of this point, or square root of 2 over 2. Square root of 2 over 2 is approximately equal to 0.7. And this is a 45, 45, 90 triangle, which is where we get that side ratio, 1 over the square root of 2, which is just square root of 2 over 2. So let's erase this triangle, and let's take a look at my x distance as I go around the unit circle. So again, my x are degrees of the angle, measured in radians in this case. You could do this, so these are measured in radians, not degrees, but you could measure them in degrees. So instead of pi over 4, you could have 45 degrees, but I'm measuring them in radians in this case, and that's my x-axis. My y-axis is that ratio of the side length, which is going to end up being the x-coordinate around the unit circle. So first start off at 0, and this is actually 1. Because at 0, on my x distance, I've gone over 1. So at x equals 0, my f of x is equal to 1, so I can plot that point. As I go to pi over 4, I go up to, or I go down to 0.7. So at pi over 4, now I'm not going all the way to 1, I'm only going to square root of 2 over 2, which is just 0.7. Now if I were to have done pi over 6 over here, if I were to have done pi over 6, I would have had a square root of 3 over 2 here, and I would have had a 1/2 here. So square root of 3 over 2 is more than 0.7, it's close to 1. So I would be up here. And then right here, if I did pi over 3, I would be 1/2. So that would be about here. So about a half. That's not a great estimation. But I could have done more values in here with my pi over 6 and my pi over 3 radians. So then as I go around the circle, I get to pi over 2. At pi over 2, my x value, you can see I use this for my sine one, my x value is going to be 0. I've gone not to the right or to the left of that axis. So I'm at 0. So at pi over 2, I'm at 0. At 3 pi over 4, I'm now negative because I went on the other side of my y-axis, and I'm negative rad 2 over 2, or about 0.7. That should probably be moved up just a little bit. And at pi, I'm at negative 1. Let's just erase a few of these. Sorry, I had that wrong there. So at pi, this is 0. So at pi, I've gone over to negative 1. This is a radius of circle 1, and I know as I've gone all the way around here to pi, my x value, I've gone negative 1. So I went ahead and plotted that pi value down here. When I put in pi radians, I get out negative 1. When I put in 5 pi over 4, both of those values are negative for both x and y, but my x value, I've gone negative about 0.7. So I'm negative here. When I get to 3 pi over 2, I've gone neither to the left nor the right, so I'm at 0 here. So I have 0 here. 7 pi over 4, I've gone over this way, square root of 2 over 2, that's positive. So notice I'm now positive. And at 2 pi, I'm all the way back to 1. And I can continue around the circle. I could do 9 pi over 4. 9 pi over 4, I've come over about 0.7, so I can plot that. And when I get up here, I've gone neither to the left nor to the right on my x-axis, and so that's at 0. So it continues, and it continues on as I go around the circle. I can go backwards as well if I wanted to go negative pi over 4. My pi over 4 is funny down here. But if I wanted to go negative pi over 4, I would just go back down here and it'd be at positive square root of 2 over 2. So right here, that's the distance I've come on the x-axis, and I can plot this, that's my height. And so then at negative pi over 2, I come down here, I've gone neither to the left nor to the right on the x-axis, so I can go ahead and plot that on my new graph, and that's at 0. And then here I'm going to plug in a negative 3/4, and I'm going to get out a negative rad 2 over 2. So I go ahead and plot that. And at negative pi, I plug in negative pi here, and I get out the ratio of the side, which is negative 1 in this case. And that's kind of a misnomer because it's sort of flat triangle, but you know that that's your cosine value, and that's down here at negative 1. And then it would continue. As I went around, you could see I'd still be negative up here until I got to 0, and then become positive again. So this looks a lot like our other graph of sine. Kind of the same values. This is really ugly looking. It should be much smoother than that. Let me see what I can do to smooth that out a bit. And if you plugged in more values for your radian measure, you'd have more points to connect. And it's going to continue on. Now cosine is also a periodic function that continues to repeat. At 0 though, I started at 1, whereas with my sine function, my sine measured my y up or down, and that was 0. So I start at 1 here. I go down through pi over 2 all the way, and I peak here at negative 1 down below at pi. It's negative 1, and then back up again. So from here to here is one section of the curve, and then it keeps going. So this is also what's called a periodic function.